Hi everyone, welcome to another video in AP Analytica. In this video, we will discuss about set theory and how to implement set operations in Python. The video is timestamped and you can skip forward to the area which you want to go. We will start with a brief introduction about sets. Sets is a collection of things. It could be anything. It could be numbers, objects, shapes, and even abstract concepts. For example, the first set is the set of vowels in English alphabet, that is A, E, I, O, and U. You can see that it is denoted by using curly braces. And there is another set, it contains numbers, even numbers to be precise. And the next set is a set of few fruits. An individual object within a set is called as an element. And we can say that an element belongs to a set. For example, we can say that the vowel E belongs to the set of vowels. In this example, we will use two sets. One is the set of ingredients for a crepe, which is named as the set crepe. It contains elements egg, flour, butter, and milk. And the next set is the set of ingredients for a cake. The set is named as cake, and the ingredients are egg, butter, biscuit, and sugar. Now let's have a look at both the sets combined. Each set is denoted by using a circle and the elements are added within the circle. Now let's see the set operations. The first set operation which we will look into is union. If we have a set A and a set B, then set A union B is set of all elements which are the elements of A and B. So the union of set crepe and the set cake will include all the six ingredients. The next set operation is intersection. If there are two sets A and B, then A intersection B means all elements common to both A and B. So in our example, crepe intersection cake will be the elements egg and butter. Next set operation is difference. Difference is denoted by using a minus sign. The difference between set A and set B will be a set of all elements which are only present in A and not in B. In our example, set crepe minus set cake will be milk and flour. This does not include egg and butter, which are elements of set crepe but are not included because they are also included in the set cake. Another commonly used set operation is symmetric difference. Symmetric difference between two sets A and B are the elements which are present only in one set. In our example, the symmetric difference between set crepe and set cake include all the elements which are included either in crepe or in cake. So that is milk, flour, biscuit, and butter. Symmetric difference can also be interpreted as the union of both sets minus the intersection of both. In this case, it will be crepe union cake, that is the whole uh, that which includes all the elements, minus cake intersection crepe, which includes just the two elements. It can also be interpreted as the union of two individual differences, that is the difference between set crepe and set cake, which is this part, milk and flour, and the difference between cake and crepe, that is cake minus crepe, that is this area which has biscuit and sugar. So that is crepe minus cake union cake minus crepe. Now let's jump into Jupyter Notebook and see how to implement this in Python. Here's the Jupyter Notebook for this exercise. This is also linked in the description. You can download it and you can do it along with me if you want. So first, let's see how to initialize a set. It can be done like straightforward by using curly braces and providing the elements within the curly braces. So here I am initializing the set grape and I am giving the elements inside the curly braces. Now I will print it and also print the type of the set. So the set includes these elements. Note that the set is not ordered, so it could be in any order. The type is set. A set can also be initialized by typecasting any other iterable, that is a list, tuple, or a dictionary to set. If you are typecasting a dictionary, only keys will be included in the set and not the value. Now I am creating a list of ingredients which are used to make a cake. So I'm calling it as cake list. And now I'm explicitly converting the cake list into a set by using the set constructor. Next, let's print the type of cake and also let's print out the elements of cake. So now you can see that cake is of the type set, and also we can see the elements of the set. The typecasting can also be done by using list comprehension. For example, I am creating another set cake version 1. This is also from the same list cake list. So here I am using a list comprehension. For all the elements in cake list, I am adding it into a set. So using literals is also another fancy way to implement the list comprehension. So that is by using the star literal. So this also does the same thing as this line. Now let's execute this cell. So both ways of implementing the list comprehension will also give the same set. Now let's see how to implement union. Union can be implemented by using union function. For example, so I am creating a new set all ingredients. It will be a union of crepe and cake, and we will print the crepe union cake. It will contain all the 6 elements. Union can also be implemented using the pipe operator. Let's have a look at that. This will also give the same result. Now let's see how to implement the intersection operation. So intersection will only have the common elements. Intersection can be implemented using either intersection function or by using the ampersand operator. First, let's have a look at the intersection function. So that is crepe intersection cake. That will give butter and egg. And let's have a look at the other way, that is using the ampersand operation. That will be cake and crepe, or the other way. That will also give the same set. The same as above, we can implement difference also by using the difference function or by using the minus operator. And let's have a look at both. If we are using a difference operator, it will be cake difference crepe. That will give the elements which are only present in cake and but not in crepe. Same can be done by using the minus operator, that is cake minus crepe. Now let's run the cell. This will also give the same results. The elements which are only present in cake but not in crepe. Now let's have a look at the symmetric difference. Same as the above operations, it can also be done by two ways, by using the function symmetric difference or by using the this caret operator. This will give a set of elements which are present only in one set but not in both. As discussed earlier in the theory, we can find the symmetric difference as a difference between union of two sets and intersection of two sets. That will also give the set which contains these four elements, same as the above, or it can also be calculated as the union of two differences, that means the symmetric difference between cake and crepe and crepe and cake. Let's have a look. This will also give the same output. That's it in this video. But there are more topics to be covered in symmetric difference, like null set, frozen set, how to add and remove elements from the sets. So those will be dealt with in another video. It will be linked in the description. If you found this video useful, please give a like and also consider subscribing to the channel for more updates. Also consider providing your valuable feedback in comments. Thank you and see you in another video.